Hey, this is Raul Smith Farak speaking. I'm an electronic engineer student from NAT. Today I'm going to explain an exercise from the subject um, electromagnetic theory and waves. The subject is the text number 2, electromagnetic waves in bounded media. First, well, there are three exercises, some questions, three exercises that we needed to develop. I'm going to explain number 3, which is related to Snell's law. First, we need to understand what Snell's law means, right? So it is fundamental for understanding how waves behave at the boundary between two different media, um, which mathematically describes the relationship between the angles of incidence and refraction for waves passing through media with varying refractive indices. Um, we just need to know in this case that, well, it can predict how much a wave will bend when it enters a new medium, which is key to, um, for example, for lenses, fiber optics, cables, and other systems where precise wave direction is critical. So the equation or the formula for Snell's law is basically the refractive indices, uh, the sin of the angle equals to the refractive index of the other media uh, times the sin of the second angle, right? So let's go to the exercise itself. In this exercise number 3, an electromagnetic wave propagates through several mediums as shown in the graph. So in here in this figure, we have a wave going through a new media. In this case, it comes from the air, through a glass, or in this case, it says that it's sweet water inside the glass and goes out of it again to the air. So what we need to do is to find out the angle of exit um, for this wave, right? We need to calculate step by step the total path of the wave until we find the angle, which is point B in here, right? The angle B. For this, we got given data. Now it says that the angle alpha number, the angle A, is Charlie Charlie, which is my number or the last two numbers of my ID, divided 2 plus 10, right? That's the angle, which in this case will be 15 degrees. Now we got for the year, we got the refractive index here in one, just one. And then for the glass or the sweet water will be 1.3. So what we need to do is just to apply the formula in this case, right? So we got the first media, uh, which the wave is going through or passing by through the second media, which is water, right? Now we just rearrange the equation for or to find the angle, the first angle, and we solve it. At the end, we find that the angle of the water when it comes to the water is 11.18 degrees. It means in here, after we got this angle, which is 15 degrees, right? In here, the angle will be 11.18 degrees. That's the angle of the wave. After that, we need to find this angle, the exit angle. We again apply Snell's law equation, but in this case, we find that we need the water information, right? And then through the air. So what we need to do is to solve everything one more time by replacing in the formula. At the end, we got 15 degrees. So it means that the exit angle is the same as the entry angle, which in this case, it is normal, taking into consideration that matches, well, is consistent with the concept that after passing through a medium and back to the original medium, the exit angle should match the entry angle. In this case, we know that the original medium where the wave comes from is the air, pass through a different media, and then comes out to the same media where it comes. So the angle should be the same. Thank you so much.